welcome to Developers Day. This session is going to cover the application engine. It's a bit of setting the table for some of the other sessions that will happen today. My name is Andy George, and let's jump right into it. And so here on the screen, we have a logical diagram, kind of working left to right. It shows kind of how data comes in and how it gets processed through our platform. And let's talk you through some of the high-level components. And so starting on the far left here, we have AMI clients and feed handlers. These are basically external applications that have data that we want to bring into 3forge. Generally speaking, these are real-time feeds of data, things coming over message queues, things being published onto topics, message queues, whatnot. And they go through something called the relay, which is a 3forge component. The relay helps basically transmit real-time data from these external systems into the center. And my clients are basically using a library that 3forge provides that's written natively in Python, and there's also in Java, C++, and there's even a .NET version. And that can be bundled into an application that's built and managed by the client. Feed handlers are basically adapters that connect directly to like Kafka or AMPs or other things. So within the relay has something called routes, which are basically ways that logic can be added to basically say, hey, we send a message to this center or to another center. Relays can connect to multiple centers. It's not visible in the diagram, but it's something they can do. So for example, if you shard data and you want to send orders with symbols starting with A through F to one center and orders starting with symbols G through Z to another center, you could write a rule in there to do that. Transforms let you do things like simply format data. So for example, if you have like fixed tags in a message and you want to replace a number with a descriptive name, transforms let you do that. There's a session on that as well that will go into depth on the performance advantages of that. Down here we have database clients and data source adapters. And so database clients are when someone uses an interface like JDBC or native Python querying to basically query into 3forge, doing various things like selecting data out of 3forge or inserting or updating or deleting data within 3forge. So very traditional database access, typically from other applications. They can also be from a query tool. And you also have data source adapters. These are things like an Oracle driver or a PostgreSQL driver. These are basically logic that, simple libraries that connect you to these other systems, and custom ones can be implemented as well. Over here within the dotted lines, you have basically the 3forge platform. And so working left to right, we have centers. Centers are like a database back end that 3forge has. And so the center has real-time tables as well as historical tables. Real-time tables have things called triggers in them. Triggers basically let you add business logic when data is being inserted, has been inserted, is being deleted, is being updated, right? Before and after. Sometimes you'll hear us refer to the concept of a CEP engine, right, for event processing, and that's really referring to our trigger framework in particular. Historical tables actually save data onto the disk, whereas the real-time tables are cached only in memory in the RAM of the computer and are more temporary in nature. Historical tables actually partition data to disk. They use a partitioning scheme. Very classically, trade date is a very common one, and so for each partition, you'll have a directory and a set of files, one for each column. You'll also have files for indexes. And historical tables let you hold large quantities of data, very similar to a time series database. So you could have billions of, if not more, records in historical tables, and they will not take the same impact on the RAM of the computer as a real-time table. We also have timers, custom methods, connectivity configurations for those data sources, and procedures, stored procedures. And these things let you do various operations. So a timer may do something like query to the historical table at some frequency, but it also may do some processing on a real-time table, or perhaps move data from a real-time table to a historical table. Moving on to the web. The web is basically our in-house built web server. And I'll mention here also that all of this stuff is completely built from the ground up by 3forge with no third-party dependencies. Things like data source adapters and feed handlers do have third-party dependencies in them, but the core platform does not. Within the web basically manages sessions for logged-in users. It's a traditional web server in that respect. And so within the web, we have basically something called data models, tables, layouts. We also have adapters in here for REST and whatnot I'll get to. One thing I'll mention at this time is that our philosophy on applications is a little different than others. So many web applications have basically stateless interactions between a web browser and the web server, meaning that the web server basically forgets about what it's doing with each client, and it's up to the client to kind of manage state and information. And so, for example, if you have a shopping cart, the state of that shopping cart is actually managed in the browser, not on the server. In 3forge, we do the opposite. In 3forge, the web is stateful. And so for each user session, there's quite a bit of data we store. When a user connects to 3forge, they're sticky and they stay connected to a specific web server. So if a user is doing something like looking at order data and they have 1 million orders in their blotter, that is sitting here in this session, and only a small amount of data, what's visible on their screen, is actually sent to the browser. And this allows us to process huge data sets, yet keep things very interactive and very responsive for the user. So data models are effectively a way of doing request response data. They use data sources and let you interact with external databases. Tables are also things like a concept here that could either be copies of data that have been queried out of real-time tables or historical tables, or even things that come out of data sources. They're little just cached versions of data. And then you have layouts, which represent basically the configuration of the screen. Layouts can do things like tabs, tables, charts, HTML forms, you name it. Also down here, I mentioned briefly, we have a REST interface that can be extended. We also have a model context protocol server that is being integrated as we speak. And then we have a workbench, which is really our IDE, right? And this is the basically authoring tool set we offer when you're in developer mode with 3forge. And then finally, we have the idea of a user profile. And so when users log in, they can save settings. They may have windows they want certain orders. They may have other filters or things they want to save. 3forge has a very sophisticated way of managing profiles, and it makes that very extendable for end user applications. Over here, last but not least, we have 2 components, which are really for load balancing, all right? And so when you have lots of users connecting into 3forge, you may want to have multiple web servers running and have like a clustered configuration. And so the web manager, web balancer let you do that. I'll start down here with the web balancer. The web balancer gives you a single point of entry. So for a single URL, basically IP address and port, you can connect to many web servers. And the web balancer is very smart. It uses a REST interface to query the webs that are available, and it figures out which one is least busy as far as the amount of memory and user sessions, and it directs the next new login to that server. That is a central point. And then you also have what's called the web manager, which acts as a virtual file system. So I mentioned profiles before. So imagine you as a user logs in on Monday to web server 1. You save some preferences. On day 2, you log into web server 2. The web manager is what keeps everything synchronized. And it basically shares the profile data across all the different webs that are running seamlessly. And so all of this stuff just works. And it all just works together really well. And, whereas sometimes people are building stuff out of lots of different third-party libraries or open source, they have to do a lot of work to make things kind of connect together. 3forge's framework just connects seamlessly together. Moving on here, I'm going to talk briefly about data flow. And so as I mentioned before in the diagram, we have real-time data, and we also have something that we call static data or request response data. And so real-time data involves message queues and topics, data that's getting published in over and over. And so generally, what we see here on the diagram on the right side, explained here on the left, is that a feed handler, and it could be an AMI client or a message queue, whatnot, it brings data into 3forge. That data goes through the relay. It lands into the center as an entry in a real-time table. There is a subscription manager within the center that is connected to other centers possibly, but also webs. And so for the web, it basically has subscriptions to the various real-time tables that you have. So for example, if you have order data coming in, you may have a subscription to the orders table. The order table feeds into a shared cache on the web. And then each user session, as it connects, it will get the order data out of the shared cache. And so an important thing to realize here is that this is a single copy of the data feeding through the platform all the way to here. Within the user session, you have basically shallow copies of the data. So because the underlying order data is a single copy, and each user basically has a kind of structure around that, allowing you to filter rows and do various things individually. From within the user session, that data kind of goes into the various panels, real-time processors, data models, real-time panels, which could be like a table or a blotter in the case of orders. Moving on, we're going to look at resting data. So resting data is request response data. And so basically what happens in request response data, you might be querying a database for like reference data. And so in this mode, data is not pushed into 3forge. Instead, 3forge is kind of pulled by 3forge. So within 3forge, a very typical use case is that a data model in the web basically creates a query, executes some sort of statement like select star from table X. That query actually is generated in the web, but is sent to the center. The center, as I showed the original diagram, is responsible for all data source adapters and all external connectivity. So in this case, that query is sent to the center. The center then basically relays that externally through the data source adapter, queries the external data source, and it could be a REST API, it could be a traditional database, or even a file. It builds a result as a table, and then it transmits that back into the session. Within the session, it may land back in the data model where it was created, and then it will also get cached in there as a table, and then it may be sent down to any subscribing data models or panels. And so, for example, if you have a simple panel where you're showing some customer reference data and you want to hit the refresh button, this type of operation would build that. An important thing to understand with data models and this kind of behavior is that you can have multiple copies of the same data. Unlike the real-time data where the system kind of takes care of resolving a single copy of the data like this form of querying and the use of data models and these statements can have multiple copies. And so if each user were to query the same external reference data in their session, they each have their own copy of the data. Sometimes that's good. Sometimes you want to go real time. So those types of architectural decisions are things we can help you with. Last but not least, I wanted to focus a little bit on the historical database, which we've done a lot of work on recently. So the historical database, as I mentioned before, lets you save partitions and files. It lets you persist things. Why would you use this database? Well, one reason you'd use this is that it has a very small in-memory footprint. And so our real-time database requires everything to be in the RAM of the computer. Since 3forge is based on Java, that basically means you have to allocate a heap size large enough. If you have millions and millions of rows of data, it could be hundreds of gigabytes worth of heap that you have to allocate to that process running. And if you start thinking about, well, I want to have 5 million orders a day over a year, how do you store that data? You cannot store that all in memory, right? And so that's where time series style databases are popular. And 3forge offers this type of functionality. And so in this case, very small in-memory footprint to this, what can otherwise be a very large store of data. It's partition-based, so it is very, has all sorts of optimizations, something we call bitmap fields, which lets you do like compression and other optimizations to how data is stored. It also has a very performant query optimizer, and it delivers results very quickly across even very large, partition, schemas. Bulk inserts have been heavily optimized. So if you are basically inserting large, vast quantities of data in a short period of time, including millions of rows per second, the system can handle it. And basically it supports some basic inner and left joins. And I think another kind of key differentiator for some of the competition is that you can stream directly into the historical database. And in some of our competitors, they kind of put everything in a real-time database for the day, and then later on they send it to the historical. 3forge lets you go directly into the disk. And it also lets you do things like subsequent updates, deletes on that data with no penalty. And so you can have a data in a partition and rewrite it. Some other databases, like I mentioned, they cannot have changes on data that's been put to a partition. One thing to mention about the historical database is it does not have the, it does not have event processing. So triggers are not available within it, but you still can interact with data with it from timers and stored procedures and, data models from the web. So still plenty of ways to interact with it. And last but not least, you can export data from the historical into standard formats, or even load it into the real-time database, so Arcade and whatnot. And that is it. Thank you.